Hello everyone, Advika this side. I'm back with another video this time. And this time we are going to discuss about inertia, which is talked a lot about in physics. Inertia. What really is inertia? Inertia. This concept of inertia is very much prevalent in physics, and I guess, if you haven't studied any physics, but you must have listened this term because it's so much popular nowadays. Not nowadays, it was always been so much popular. What is inertia? Oh my God, I just started from the wrong place here. Just start from up. Inertia. Got it, inertia. So, let's say there's a ball moving with a constant velocity u, and while it's moving with a constant velocity u, this ball, when this constant velocity is removed, let's say for t seconds, this constant velocity is been given to this body for t seconds. But after t seconds, this constant velocity has been removed from this body, and the motion is still continuing. Why is it? Why is the motion of body still continuing? We have removed the force which we were giving it initially, which was really moving it further. But now, when there is no initial force, the body is still continuing, but its velocity is declining with time, slowly, slowly, and slowly. So, why doesn't it happens that if we take a body and we put some force onto it, and just after we remove it, it doesn't move? Let's say we are applying a force of U newtons onto a body. It starts moving, it rolls down, it shows us a very great effect. But as soon as we remove the force, the body continues its motion. Why? Why does the body continue its motion? So that's what we need to understand. So in EGU, we need to take it more conceptually. Inertia is this thing only. The body is resisting. The body cannot change the virtue of its motion by itself. It needs some external force. As in this case, we are applying an external force. As in this case, as it's slowing down, it's because of the friction, air resistance, which are acting against it, air resistance, friction. If we remove it, let's say we are in space right here, it's our space, and if we go in space, if we apply, let's say, a U Newton force on it, it's gonna move with U Newton if we move it. So it's in one time force, one time. And that's how our rockets work. As soon it takes fuel to, go out of Earth's atmosphere, but it doesn't takes much of the fuel to travel in space because there is no air resistance, no friction. It's our rocket right here and it's moving to space. There is air resistance, zero air resistance, AR, Oh my God. AR and zero friction. So this body is going to move with the same velocity u until some external force, let's say there is a comet, which hits it and it stops it. Until there's some external force acting on this body to stop it, it's gonna move with the same velocity u. This is what inertia is. So, as we are cleared with what inertia is, let's move on to different types of inertia. It's gonna be of three types. One, two, and three. Hope you're enjoying my drawing. Okay, inertia of rest. The first one is rest. The tendency, so basically the tendency of a body which is kept on rest on a table, let's say, to be on rest is what is inertia of rest talking about. So a ball which is kept somewhere, let's say on floor, and it's not moving, it has zero velocity, nothing is acting upon it, nothing. Net force is zero. It's in a rest position. This body won't move until some external force, let's say of V Newton, acts upon it until this external force acts upon it. Until this V Newton force acts upon it. Now, I guess we are cleared with inertia of rest. The next step is inertia of motion. Let's say there is a body moving with a constant, not a constant, with a velocity 10 meter per second. 10 ms. Okay, 10 meter per second. So the tendency of a body to remain in state of uniform motion. So it is going to resist that change. So the tendency of an body, let's say the force which is moving this body, U, newtons, is removed. The body will still tend to move in 10 meter per second. It will still tend to move in 10 meter per second, but there is some external factors, let's say environmental factors, or let's just neglect them for a moment. If we put in U Newton force and remove it, the body is going to be in the same position when we applied U Newton and after we didn't apply it or we stopped applying U Newton force. This is what inertia of motion is. And inertia of direction. Let's say a body is moving in north direction. It's simply to visualize. N. And we apply a force somewhere around here to make it go in this direction, northeast. Just a lame example here, just an analogy to make you understand. So the body resists this change. The body resists this change of moving in northeast direction. Are you getting my point? The body is inability to move by itself unless until there is some external force acting upon it. You need to always keep in mind there is some external force acting upon in inertia. Always. Great. Mass. Now, mass also plays a very big example in inertia. Not an example, very big role. Let's say you have a ship here, which is an alien ship, okay? It's moving in space, let's say, okay? You applied a heavy amount of almost, you can say, 100,000 Newton force onto it to move it with some velocity, okay? To move it with some velocity. Now, the inertia of this very big mass, m, is going to be higher as the mass is directly proportional to inertia. Mass is the measure of its inertia. If a body has more sorry, not mass, it's gonna be, if the body has more mass, it has more inertia. Simple as that. M is directly proportional to I. It is simple. That's perfectly fine. Okay, let's just give a rapid revision. Inertia is nothing but when it's the inability, or the, we can say, the tendency of a body to remain in a certain way or certain state, certain state. To remain in that certain state is inertia, and opposing the change. So we have three types of inertia: inertia of rest, inertia of motion, inertia of direction. Rest is when an object is at rest; it would be at rest un unless until any external force acts upon it. An object will be in motion unless until there is some external force acting upon it. Next is this direction one. The object will follow in north direction unless until there is some external force acting upon it. Super clear? Super clear. We will do it. Thank you. Thank you very much. Meet you in the next video.